Covalent bonds. This is the second worksheet, part 2. We're going to continue on with covalent bonds. These are the properties of molecular compounds. So, why do we call covalent compounds molecular compounds? Because chemistry is designed to be confusing. Now, these properties are going to be very dissimilar to ionic, so pay very close attention to these. Covalent bonds have low melting points. They can be solid, liquid, or gas, whereas ionic was just solid. They may dissolve in water, but maybe not, whereas ionic will always dissolve in water. And they do not conduct electricity well. So they are almost opposite of ionic bonds, but not completely. And lastly, they are not considered weak bonds, but they are considered less strong bonds. We're now going to take a look at how to name covalent bonds. There are 3 rules. The first one being, remember they are 2 nonmetals, so you take the first nonmetal and just name it. And like with ionic, we're going to change the second one to IDE. And there's really not a 4. On the third, we assign prefixes to both nonmetals by looking at the subscript. That's that little number down below them, except for mono, which we would put mono on the first nonmetal. Now, this note, when you have the addition of Greek prefix, places the 2 vowels adjacent to one another, the A or the O at the end of the Greek prefix is usually dropped. Example, non-oxide would be written as non-oxide, and monoxide would be written as monoxide. The I at the end of the prefixes di and tri are never dropped. Let's take a look at the prefixes now. Oops, I looked at my wrong list there. Prefix for having 1 atom would be mono. 2 is di, di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. I would like for you to go ahead and write down 7, 8, 9, and 10. I will put them out to the side. 7 is hepta, H-E-P-T-A. 8 is octa, O-C-T-A. 9 is nona, N-O-N-A. And 10 is deca. Just a couple of questions here. Number 1, explain how many molecules a single covalent compound can have. As you can tell from this one, they can be very, very long, as many as needed, up beyond 100. Question 2, you need to think about this one. You have a white crystalline solid and find that it melts at 86 degrees Celsius. Is it covalent compound or ionic? And why or why not? Well, I'll give you one hint. Anything that is below 300 degrees Celsius is considered a low melting point. So what do you think? It is covalent. Why? Well, because the melting point is below 300. So therefore it is considered a low melting point, and you can have a white crystalline solid that is also covalent. All right, now we're going to put into practice the naming that you learned just above. I would like for you to pause the video, and try to do 3A, B, and C on your own. So please pause the video. First step is we name the nonmetal, the first nonmetal, and we would add a prefix unless it's on the first and there's only one, and that so then we would just say nitrogen. Then we take the second nonmetal, we add IDE to the end, and we add the prefix. So this prefix is 2, which is di. So it would be nitrogen dioxide. Pause the video again and do B, please. So we name the first nonmetal using the prefix, unless it's a 1, and in this case it is a 1. So it is just sulfur. We add IDE to fluorine, so it would be fluoride, but we add the prefix for 6, which is hexa. Sulfur hexafluoride. So pause the video and let's do C. Name the first nonmetal. I would use a prefix, except for it is mono, so I would not. So it would be sulfur. We add IDE to the ending. It is 2-dioxide. Now, I want you to do the reverse. Now you're going to try to give the equation, which I think you will see this will be much easier than what we had to do with the ionic. So I'll work the first one with you. Dihydrogen. So we know di is 2. Monoxide. Mon means 1, and it is implied. So dihydrogen monoxide would be water, H2O. Xenon, and xenon has no prefix, so therefore it means we must just have 1. Tetrafluoride, tetra meaning 4, so we have 4 fluorines. Lastly, we have dinitrogen, nitrogen, we have 2 nitrogen, hexafluoride, so hexa would be 6, so 6 fluorines. See, that was much easier, wasn't it? I'm sorry, can you tell I'm trying to hurry? Not PB, P is phosphorus, there's only 1. Br is bromine, we would change it to bromide, IDE, but there are 5, and that prefix is penta, phosphorus pentabromide. Pause the video and let's do number 6. In this case, we are going to be writing the chemical formulas. Tetraiodine nonoxide, tetra meaning 4 iodine, nano is 9 oxygen. Pause and let's do number 7. phosphorus, there just must be one. Pentafluoride, which is fluorine. Penta representing 5. Last one for me to work with you. Pause the video. Dinitrogen is 2 nitrogen. Monoxide would be 1 oxygen, and the 1 is understood. All right, you are ready for your assignment. You need to come up to the desk and get that, please.